Sam invested $2,000, so he's going to, if you look at the chart, they provided a chart for us, so let's go ahead and fill it in. Investment A, he invests $2,000, okay? And it's at 5.25% interest. That's 5.25% interest, okay? Now, if he's invested $2,000 at 5.25% interest, and basically, if you look here, they don't tell us how long, but we're just going to assume a year because that's all we can do if they don't tell us anything is assume a year. If I want to know how much interest he's going to make, which is what this last column is, I would just multiply 2,000. Am I going to multiply by 5.25%? Do I multiply by percents?
No, you multiply by decimal.
Yeah, 0.0525. That's why you want a calculator again, right? You don't want to be doing that if you don't have to. And then he's got lots of money, so he's going to invest in something else. Yay for him. He's got $3,000, and he's going to invest it at 8.5% interest. Okay, so if we want to know how much interest in a year that he's going to make off that, it would be this 8.5% times 3,000. So let's see, $3,000, and if I'm going to multiply by 8.5%, that's going to be what, 0.085? Now you could be getting these numbers in your calculator because you're going to need them in a minute. They want to know what percent is he earning on his total investment. So he's earning 5.25% on part of it. He's earning 8.5% on part of it, but he didn't split it up evenly, did he? I can't just average the two percentages because he didn't split it up evenly. He put more over here. He put more at the higher interest rate than he did at the lower interest rate, which would be smart investing. We know what total amount of money he invested. We could add that in. What was his total that he invested?
5,000.
Yeah, 5,000. So I'll put it down here in a different color. Now, what his interest rate is going to, his like kind of net interest rate in a way, we're going to call that X. We don't know what it is. We're going to call that X. Now, I can let X be a percentage, or I can let it be the decimal value. Aren't we calculating the other stuff in decimals? So we're just going to, we may have to do a little interpreting when we get done. Shouldn't his interest rate, when we look at this overall, shouldn't it be somewhere between 5.25 and 8.5%? Yeah, it's not going to jump to be greater than that. It's not going to be less than that. It's going to be somewhere in between. So we'll kind of have to look when we get to the end and think about what are we getting here. Couldn't I represent his total investment as $5,000 times his net interest rate, which means what he really kind of is getting overall when you take all things into account here. So his total investment, this is so exciting, Kaylee, isn't it? His total investment will be 5,000 times X. Is it okay with y'all if I just write it like 5,000X, right? It's going to be the amount he earned from investment A plus the amount he earned from investment B, okay? So from investment A, because we have this nice column, we have 2,000 times 0.0525. Did anybody get that?
105.
105?
That's what
Like 105?
Yes.
Okay. All right, and what from investment B, we know he got 3,000 times 0.085. I could put that in there, but if we go ahead and multiply it out, what's 250? Okay. 255, okay. All right, so 5,000x is equal 105 plus 255. That'd be what, 360? Y'all can get me if I mess up on the math here. So what would I do to find out what his interest rate was here? To solve for x, what would I do, in other words? Here's the x.
5,000 divided by 50.
Well, remember, we want the x by itself, so we're trying to get rid of this. Yeah, we're going to divide by 5,000. If you circle the variable, it kind of helps you remember, oh, I'm trying to get rid of the thing with the variable. So if you take 360 and divide by 5,000, what do you get? 0.072? Okay, so do you think that means he got 0.072% interest?
No.
Now that's the decimal value. That would change over into 7.2%. That's what he's making. That's kind of what he's making on his entire investment. It's somewhere in between the two amounts that he invests. Okay, the problem says how many liters of water must be added to 50 liters of a 30% acid solution in order to produce a 20% acid solution. Okay, let's make a chart, because that chart seemed to really help, didn't it? Just kind of have a place to put everything. So we've got the amount we have of, the first top thing they mentioned was 50 liters. And what's the percent solution? We have 50 liters of 30% solution. So wouldn't we say that we have, in all, wouldn't we say that's 0.3 times 50 would be kind of the amount of solution at 30%? Because 30% would be 0.3. So this would kind of be, let's see how they labeled it on some of these other charts over here. It's kind of like the amount of acid here. It could have been the amount of grape juice concentration. It just happens to be acid here. So if the acid thing is messing you up, just think it's just a percentage of how concentrated something is in a solution. Then we have you're going to add some water, okay? So how much water we're going to add? So this was the first solution. We're going to add water. How much water? X. We don't know.
Would it be 50 plus X? Or?
That's going to be our total. In the end, if we think about our total, let's go ahead and think about our totals as we go. That means we're going to have 50 plus X, right? We want to have in the end, don't we want a 20% solution? Okay, so if I think about that in the end, I'm going to have 0.2. That's 20% times 50 plus X. How much percent acid's in the water?
30.
Well, no, it doesn't have any in it. Actually, what aren't we watering down an acid solution here is really what we're doing. So if we want to know the amount of acid in there, that would be 0 times X, which is 0, right? We have 0 acid in that amount of water. We're not adding any acid to it, but we're actually going to be watering down what we already have. So when we get done, if we think about the amount of acid concentrate, we want to end up with 0.2, this total right here, times 50 plus X. That's going to be the amount of the 30% solution, or the concentration. We're focusing on concentrations of acid here. Can't spell concentration. Let's put concentration here. I want a 0.2% concentration, and this is how much I'm going to have. Now, on the concentration that I started with at 30%, we said that was 0.3 times 50. That's 30% concentration, plus the concentration of acid in water. Well, 0% times 0 is 0. It's okay. That's okay. It looks a little weird, but it's okay, because we're accounting for the amount of water we added over here when we got 50 plus X, don't we? If I'm going to add some stuff and it's 0% concentration, I'm not adding any acid to it. I could have left that plus 0 off. I just wanted to show you that's where it would go. So I've got, let's simplify the right-hand side first. 0.3 times 50, wouldn't that be 1.50 or 1.5?
15.
Oh, 15, you're right, 15. There's one, it's 150 with one decimal place, thank you. And then here, 0.2 times 50, 10 plus 0.2x, okay? So I could subtract 10 from both sides. And let me come over here. I would have 0.2x is equal to 5. X equal 5 divided by 0.2. X equal 25. Okay, so I would need to add 25 what would this, liters or whatever this was, of water in order to water down that 30% solution to a 20% solution. There we go. So many numbers here.